Good morning, dear students. So, as I told you that we'll be doing the 5.1 exercise, the last questions, and we'll complete that exercise. And in the same video, we'll be going to head to the next topic, that is argand planes. Alright, so let's get started. See, try to understand this question. Find the real value of theta such that 1 plus I cos theta upon 1 minus 2I cos theta is a real number. That means for this question, it should be a real number. So we need to find such value of theta. After putting here, this should give us the real number. There should be no imaginary number in it. Okay, so we need to find the real value of theta. That means we need to put such value of theta here so that this I and this I should be removed and we only get the real number of it. So as we see that in this question, you have this I and this I with cos theta and cos theta. So see, this theta, we need to remove this term and this term, otherwise, and then we'll get the real number. So as you see that if you put theta equal to 90 degree, what is cos 90 degree? 0. That means this will become 0, this will also become 0, and finally you will get the real number. Okay, so this is the real number also, as theta is 90 degree. This is the real number, this is the real value. Okay, so one value can be theta equal to 90 degree. That means cos 90 is 0. That is why this I will be removed. Now one more thing is there, that not only on theta equal to 90 degree in cos it is 0, on other angle also it is 0. So let me explain you one very important concept of trigonometry. If we have not taken in the trigonometric part, just try to understand here. If you are asked that at what angles your sine cos 10 will be 0. So as we know that for the sine 0 degree we have 0, cos 90 degree we have 0, and 10 0 degree we have 0. Then at which angles your sine cos 10 are 0. So you understand one thing, that after every 180 degree your angle becomes 0. You know this, I have explained you, this is 0 degree. After 180 degree again your angle is set up here, so it is 0, and after this 360 degree, so it is 0. So what you have to understand, if you add 180 in this 0 degree, that means sine 180. So at sine 180 your answer is 0. Again you add 180 in it, so sine 360 it is 0. So you have to remember like this: 0, 180, 360. Then you have to add 180 degree in it, and you will get, at that point you will get answer as 0. Similarly, at cos 90 degree you have 0, so add 180 degree in this 90 degree, so what you will get? 270, because 90 plus 180 is 270. Then after 270, 450, then 90, 270, 450, at this angles your cos will be 0. Similarly for tan, if tan 0 is 0, then tan 180 will be 0, then tan 360 will be 0. So like that you have to remember. Now as I explained you here, that at cos 0 degree it will be 0. So cos 90 degree it will be 0. So cos 270 also it will be 0, and cos 450 also it will be 0. So we need to consider all those angles, that is pi by 2, 3 pi by 2, 5 pi by 2. Pi by 2 is 90 degree, this is 270 degree, and this is 420 degree. I have written in terms of pi. So we need to write it in this form, and as this is the general answer of this. You know what is the meaning of general answer and particular answer. This is called the particular answer and this is called the general answer. So generally we will give the answer of this as the theta should be 2n plus 1 into pi by 2, where n belongs to integers. Integers means all the positive numbers and negative numbers, and including n equal to 0 also. Okay, as you can find this thing, see, this is an AP. Okay, this is nothing but AP, and you know how to find the nth term of an AP, a plus n minus 1 into d. So like that only it happened. Okay, let us understand this question. The very last question of the exercise 5.1. Modulus of z1 equal to modulus of z2 equal to modulus of z3 is equal to modulus of 1 upon z1 plus 1 upon z2 plus 1 upon z3 equal to 1. Then we have to prove that, we have to find the value of modulus of z1 plus z2 plus z3. What will be the value of this thing? Okay, so for understanding this question, I just need to clear some of the things with you. See, let us consider z is equal to x plus iy. If I ask you what will be the modulus of z, then what will be the modulus? X square plus y square. You will answer. On the other hand, if I ask you what will be the conjugate of this z, so conjugate of z will be x minus iy. And if I ask you what will be the modulus of the conjugate of z, so you will say it will be like this, which is same. So can you understand one thing, that modulus of conjugate of z is equivalent to the modulus of z, because these two are equal, then these two should also be equal. So you keep in mind this thing. Okay, so I'm writing here this property. Okay, one more thing you need to understand. See, as I considered x is equal to z is equal to x plus iy, and z bar is x minus iy. So what will be z into z bar? X plus iy into x minus iy. A plus b, a minus b, which is a square minus b square, or x square plus y square will be the answer. So z bar is equal to what? X square plus I square. So as in, this is also what? The same, no? So we can write this is equal to z bar. Are you understanding this thing? That we can write, because modulus of z is also what? X square plus y square, and this is wait, if I square this, see, modulus of z square, what will be? That means square of x square plus y square, the whole square. Square to root, it will be cancelled. So modulus of z will be what? Z bar. So you need to remember one thing, that modulus of z bar is z bar is equal to modulus of z the whole square. Now let us get back to our questions. We are given with z1 equal to modulus of z2 equal to modulus of z3 equal to 1. Okay, now square all the sides. So this will be like this. 1 square is 1 only. Now as I told you, z1 bar can be written as z1 z bar, z2 z bar, z3 bar equal to 1. Now equalize this is equal to this. So z1 will be equal to z1 bar will be equal to 1, z2 bar equal to 1, and z3 bar equal to 1. From here, z1 bar will be equal to 1 upon z1, z2 bar will be equal to 1 upon z2, and z3 bar will be equal to 1 upon z3. Now as we have this also, so 1 upon z1 can be replaced with z1 bar, so z1 bar. This can be replaced it with z2 bar, and 1 upon z3 bar can be replaced it with z3. Now they all three are bar, and I told you one property, that this can be written as like this. Okay, this is also bar, this is also bar, this is also bar, so we can write the whole bar. Okay, now as we know after this thing, and as I have told you the very beginning, the property, that modulus of z bar is equal to modulus of z. So modulus of z the whole bar, it can be written as z1 plus z2 plus z3. Okay, if this is equal to 1, that means this is also equal to 1. Okay, because we are equating this. Actually, I need to write 1 here equal to 1. Then this step is equal to here and equal to 1, which is going on. Then after this to this equal to. So finally, modulus of z1 plus z2 plus z3 is equal to 1. Okay. Okay, let us head to the next topic, that is eigenplanes. So what do we mean by eigenplanes? So first of all, let us understand the things which we already know. So what we know about the coordinate geometry. What is that? Okay, as in the coordinate geometry, this is called the x-axis, this is called the y-axis. Okay, and we have a point, okay, that is xy, where x is called the abscissa and y is called the ordinate. Okay, and with the help of this geometry, we used to find the distance between the 2 points, or we use the section formula in it. And we also prove, sometimes we are given with 4 points and we need to prove that this 4 point constitutes a square, parallelogram, rhombus, by the help of distance formula, section formula, and so on. So similarly, what do we mean by the eigenplanes here? Say, for the real number, you have coordinate geometry, a specified point, and some theory related to it. So as the complex number, as this is a number, so it is also have some geometry of it. Okay, so what is that geometry? The coordinate plane that represents the complex number is called the complex plane or eigenplanes. Okay, that means this also have some geometry. If I want to denote a point that is 2 plus 3i, so this is also called a point. I can denote this 2 plus 3i in this particular plane. How? See, this first term represents the x-axis and this second term represents the y-axis. So basically, I just want to make you understand one thing, that the x-axis, this is the real plane or real axis, and this y is called the imaginary axis. The only difference you need to understand, that y-axis will become the imaginary axis and the x-axis will become the real axis or real plane. Okay, so what all things you have studied in the coordinate geometry regarding the distance formula, section formula, and all those concepts, they are like a copy paste in these things. Say for example, if you have the 2 points x1 plus I y1 and x2 plus I y2, and you need to find the distance between these 2 points. So what will be the distance formula? We know what is distance formula: x1 minus x2 the whole square plus y1 minus y2 the whole square. Okay, so this is only the distance formula between the 2 points, the 2 complex numbers also. Okay, so the concepts are same. Okay, we don't have to study some other things in it. All the things will be same. In place of the real number, we need to put the complex numbers. Okay, then after that, there comes the next topic, that is triangle inequalities. This has been excluded in the latest syllabus, the reduced syllabus, so you don't need to do the questions regarding the triangle inequalities. Okay, now exercise 5.2, let me just give you, there are total 4 questions. In those 4 questions, you are familiar with all those 4 questions. Okay, the first question says to find, you are given with the points, 3 points, and you need to prove that those 3 points are the points of equilateral triangle. You know the property of equilateral triangle, as all the sides are equal. This point is given, this point is given, this point is given. Find the distance formula between this and this. If they all 3 came equal, then that is the proof for the equilateral triangle. Similarly, in the second one, you need to go for the collinearity. Collinear means 3 points are on the same line. They are lying on the same line. Okay, so if this is A, this is B, this is C, so you prove that AC is equal to AB plus BC, then it will be proved. You know how to find AB, BC and AC by the distance formula. In the third question, you have to prove it is a square. You are given with all 4 points. Again, the distance formula you have to use and prove this thing. In the fourth question, you have to prove they are the vertices of the parallelogram. Okay, that also you know the properties of parallelogram. Opposite sides are equal and the diagonals are not equal. Okay, so like that you can do this exercise. Then we'll see the next, that is polar representation of complex number, in the next video. Till that, write these things and do the practice, and you have to do 10 examples of 5.1 exercise in the copies and examples of 5.2 exercise also. This will be your homework. Okay, so thank you so much. Have a nice day. Bye bye.